Hello everyone, my name is Austin Rovinsky, and I'm an assistant professor at New York University. This is the 7th lecture in my mini course on physical design databases, and this lecture will briefly introduce you to the OpenSTA adapter. Previously, we discussed the differences between OpenRoad's two databases, which are OpenDB and OpenSTA. As a reminder, OpenDB mostly holds physical information about the design, and OpenSTA's DB holds mostly logical and timing information about the design. OpenDB follows the taxonomy presented in the prior lectures, whereas OpenSTA mostly adheres to the taxonomy used in the Liberty timing model. Here's a list of some reasons why you might want to use the OpenSTA database, although discussing how to do these is beyond the current scope of this mini course. One of the top reasons for using the OpenSTA database is for calculating timing paths. This can be used to calculate the circuit delay through a specific circuit path, or it could be the rise and fall times of a specific gate, or it could be the fan-out, or it could be several other things. It could also be used for tracing connectivity, such as finding the paths between a specific start and end point, or it could simply be for reading Verilog. OpenSTA is the tool that processes Verilog netlists when they're initially read into OpenRoad, and then translates those into the internal database representation. OpenDB, on the other side, is used for handling the def files. And there are several other use cases that you may want to use OpenSTA as its DB. Here's a quick rundown on objects in OpenDB versus their corresponding objects in OpenSTA. Masters in OpenDB are cells in OpenSTA. Insts are instances. Both I-terms and B-terms are actually mapped to terms in OpenSTA. And M-terms are ports, and nets are still nets in OpenSTA. Fortunately, there's a convenient way in OpenRoad to convert between these two. To convert OpenDB to OpenSTA objects, you can use the db to STA function. To convert the other way, you can use the STA to DB function. Do note that these functions aren't creating a new object, they simply return a pointer to the corresponding object in the other database. So for example, if you were to make a call to db to STA on a db master for an AND gate, the function would return a pointer to the corresponding cell for the AND gate in OpenSTA's database. For a full list of the possible conversions, you can look inside the db network header file. This header file is important because it will need to be included if you plan to do any conversions in your tool. One question that might come up is, what should you do if the databases get out of sync? For example, what if you're modifying one database and then you're reading from the other? Fortunately for you, the databases are kept in sync through callback mechanisms. This means that any update on one side should also be applied to the other side, assuming that you're using the proper interfaces for accessing objects. So that's all for this lecture. I'd like to take a moment to thank Nordtech, which provided the funding to make this mini course possible, and thank you for taking the time to watch it. I'll see you next time. So that wraps up everything for this lecture. I'd like to take a moment to thank Nordtech, who provided the funding to make this mini course possible, and thank you for taking the time to watch it. I'll see you next time.